So, good afternoon, everybody. The name of this talk is Harmonizing Information using Elixir for data sonification, which is a topic that I've been exploring in the last months. So, I'll start to introduce myself. My name is Carlos. I'm a software engineer. Unfortunately, I don't work with Elixir. I know that's pretty sad, but I'm planning to change it. So, Elixir for me is like a hobby. And another hobby that I have too is music, so it's cool that this topic is like the mix between those two fields. Here's my GitHub and my mail. So let's start with the goals of this talk. I will start explaining what data sonification is, then we'll have some introduction to music theory. How many here has some knowledge in music theory, just to know? Oh, that's perfect, that's cool. You don't need no prior knowledge in music theory. I will start explaining some concepts I think everybody will be able to understand. Then I will start talking about the MIDI protocol, and then we will run some examples on Livebook. I should say that my main goal with this talk is that by the end everybody can go home and start experimenting, if you want, creating sounds using Elixir. So let's go. What's data sonification? In simple words, it's the presentation of data as sound, and you can do this for analysis and interpretation. And it has application in many fields like science, art, and accessibility. So some reasons to do this. As everybody knows, we mostly perceive data through images, but we can also recognize some patterns and some trends, and even communicate ideas through audio. So you can get another perspective from data, and this happens because we have distinct memory for a specific sound cluster. You can also enhance the data visualization, since you can play both together, so creating this multi-parameter observation. And then it's cool for peripheral use. So imagine you are in some art gallery, and there are a lot of arts related to some topic, and the music that's playing on the background is some sonification from the data related to the topic of the art exhibition. So it's cool for create this experience too. And it can also increase accessibility, since we are creating another way to consume data for people who are blind or have some visual condition. So a good example of data sonification is the work that NASA have been doing. They are kind of pioneering in sonification. So since sound cannot propagate in space, that's cool for create some experience. And mostly they are translating the images in sound. So when you got a high level of brightness in the image, they are using sounds like with high pitch and loudness. So it's cool for public engagement too. So how are we going to do this? We're going to do some data processing. This can be ordering a CSV file, or we're going to do normalization of the data. Then we define some sonification parameters, and then we will convert data points into sound. So in a sense, it's all about mapping, and that's nice using Elixir because it's a functional programming language. So it has map function, and yeah. So now I will talk about some music theory concepts. I will start talking about some elements in music. The first one is melody. So melody is when you have notes being played through time. So it's like the horizontalization of pitch. You have the concept of scales. Scales are kind of a group of notes that you can pick to create a melody. So you have different scales with different vibes, like major, minor, pentatonic. Usually the major sound happy and the minor sad. And then melody is cool because it can be used as a mirror for trends. Like imagine your data points are increasing values, so you can start playing notes with a higher pitch, or you can lower if they are decreasing. So we have harmony too, different from melody. It's when notes are playing at the same time, so it's verticalization of pitch. And when you got notes playing at the same time, you got something called chords, and chords can be consonant or dissonant, and this is related to the interval between those notes. So with consonant chords, you got a more pleasant sound, because the notes has a stable relationship, and dissonant sound don't sound so well together. Like dissonant needs some solution from the consonant chord. So it's cool. Harmony it's cool because you can use to establish some relationship between different data variables if you have data points happening at the same time. And when you convert this to a sound, you gotta have notes being playing at the same time and creating harmony. So we have riffing too. It's like the time in music. A good example in riffing is the heartbeat. It's like it's a riffing that everybody got inside. And it's a good example because we can, with the heartbeat, we can recognize the pattern of if your heartbeat is at a high frequency, you probably should see a doctor. And it's cool because data sonification is like this. You are using musical patterns to get some conclusion. So you got syncopation too. That's when you change the regular flow of riffing. So you may be anticipating some note and playing it offbeat. So it can be used to, if you want to emphasize some data point in your data set. So riffing is cool because, as I said, it can represent temporal patterns. Like if you have a high frequency amount of data through a specific time, you are going to use fast riffings or slow riffings to represent not a lot of data. So even the spatial patterns you can use because we can convert the space in time when we put it in music. So other elements, we got timbre, that's related to the instruments that you're going to use. Like a guitar has a very specific sound, and a piano has another sound. So we got dynamics too, and this is related to the loudness of the notes that are being played. So here you got a lot of Italian names like mezzo piano, pianissimo, forte, fortissimo. All those names are related to levels of loudness in music. And you got texture. That's when you're creating layers in music, like you can play a lot of melodies together, or you can even play a melody on top of harmony. So, okay, now let's talk about MIDI. MIDI is the acronym for Musical Instrument Digital Interface. MIDI is a protocol, it's not audio, and it's supported by a lot of hardware and software. And here in this presentation, we're going to use the GarageBand to receive the MIDI message. So MIDI works sending message that represents musical actions. So the devices will understand and reproduce it. And with the message, you have status bytes and data bytes. So this is the list of messages that you can send with MIDI. The notes off and note on is related when the note is being released or pressed. So you send as a data one the note number that will represent the pitch that you want, and the velocity of the action, it's more related to the attack or release. And after that, you have polyphonic capture touch, and this is related to the pressure in some notes that are already playing. So you need to send the note number and the amount of pressure that you want. You have control change that's related to the settings of the MIDI device. So you can increase the volume of the device and change up the settings that it's programmed. So you have program change. That here you can change the instruments that you are using or the channel in the MIDI device. And channel after touch is pretty similar to polyphonic after touch, but instead of being applying only one note number, you're going to be applied to all the notes that are playing, so you only need to send the pressure. And the pitch wheel is when you need to modulate the pitch of a note, of all the notes that are being playing. So in this case, we need more than one byte to send. So in data one, you send the less significant byte, and in data two, the most significant byte. So for some curiosity, this is like the notes related to the note numbers in MIDI. I can say some fun thing here, like all the white keys in piano, they are the C major scale. So if you only pick notes from the white keys, you can create a melody that makes some sense because they belong to the same scale. So, and the black keys, they are the G sharp minor pentatonic scale. So, okay, now let's I will open the live book, and then we'll create a connection, and then we'll send a message like this one. And and here you can see that it's a binary that we'll be sending. So here I got the example. The library that I'll be using is the MIDIX. So here I'll create a connection. And then I will send 3 notes. And here is the note on and the note off event. It will last half a second. So it will be 3 notes lasting half a second. So. It seems like the sound. Wait. I tested it before, it was working. Why it's not working? Yeah, it was. Wait. Yeah, the GarageBand is receiving the. Yeah. Okay. Can you check, please, the sound? It's not. Okay. The sound that I'm playing here, I tested it before, but. Okay. So yeah. So this was the 3 notes. No, it's just a beginning, just an example, and then. Okay. So yeah, that's cool. But now let's translate data into sound. And to do this, we will need some data set. There's a very good website called Lisbon Aberta. You have a lot of open data related to the city of Lisbon. And in different fields like education, sports, and economy. So the first one that we are going to use is related to traffic conditioning. So you got a list of events. You've got if it got a relevant impact or not relevant, and then yeah, you got the reason why the traffic conditioning happened. So okay. Yeah, here I'm importing the libraries and then opening the connection. And here I create a map relating the events with the C major scale. And here I'm creating the function to play every note, like every note will last half a second. So here I'm doing the map, and then I did a funny thing here. I made a conditional that if it has a relevant impact, it will play the note normally. But if it's not relevant, it will play the note 3 octaves below. So that's why I'm subtracting 36. 36 is because it's 3 multiplied by 12. So when I play this and when you hear lower notes, it's related to not relevant events. So let's see. Yeah, that's pretty avant-garde. I don't know how to describe this. But yeah, interesting. Now, it was an example only using melody. Now let's create an example using harmony. So for this, I will need more than one data point happen at the same time. So I picked the data set related to annual average temperature anomaly in the city of Lisbon. You have the maximum, the minimum, and the average. So we got a 3, and we're going to play 3 at the same time, so it will create a chord. And I separate in 3 different channels, and everyone is related to some instrument that I believe has some kind of feeling to the data, like the average is an organ, and the minimum is a bass, and the maximum is a vocal synthesizer, so the maximum has a kind of warm feeling. Okay, let's play it. I even made a data visualization that so you're going to see the sonification together with visualization. And I'm using Kino.js for this. I already saved it as a WAV file, so I'm going to play the two together. You can see that the values increase through time. That's not good. Okay. I showed this to my girlfriend. She said that it sounded like a Philip Glass soundtrack. And so for some curiosity, I use the pentatonic scale in this one. And yeah, so some next steps. I would like to explore more the interactive side of Livebook. I found it a pretty nice tool. And I'd like to expand this to see it functioning in some art performance and things like that. I think it should be really interesting. And I'm also searching for some community development to try to find other people that are kind of saying the same stuff in Livebook, doing multimedia things like playing audio and graphics and things like that. So here are all my references. And it was a pleasure to be here. Thank you, everybody.
All right, thanks, Carlos. Any questions? We've got plenty of time. Yep.
Hi. Can you hear me? Yeah, okay. Thank you, Carlos, for the presentation. My question is actually more of like a questioning, maybe, of whether we can achieve something like this. You talked about how to get data and transform it into sound, but like I myself, as a developer and a person who likes music, plays it and enjoys like jazz, maybe Philip Glass, something like you mentioned, right? What could be, maybe probably you have questioned yourself about this, what could be the use of that in the inverse way, like using sound to get data for us, maybe like extracting something like from Giant Steps from Coltrane, right?
Cool. You're talking about making data from music instead
of... Yeah, exactly. Like, because we have already a lot of sound, how can we get data from that the other way, right?
That's really cool, because with music you can perceive like the style of some interpreters, like piano interpreters. Like I said for example, when I said about the message in MIDI, you have some things related to the pressure on the key, and it's something that's not in musical sheets. Like it's the expressiveness of the people that's sure. Playing. Like yeah, and I already saw a work related to this too. It gets a lot of classical music interpreters, and then they map the expressiveness of the people that play.
Sure.
Like you can get when some people has applying more pressure in some notes. It's all related to the expressiveness of the player. So yeah, I think it's funny. It's a funny example that I remember when you said about it.
Sure. So we could try in getting, let's call it that velocity, right? So we could try getting velocity and other state, because like those types of art relate to people, right? People talk for these arts for like 50, 60 years, right? So maybe the other way could be something that incentivizes other art itself, not only for money and not for other companies, but also for art itself, right? We could try. I'm just rambling here to see if we can get something out of it.
You think you get the data from music, like you think you understand why Glenn Gould is so genius, important playing Bach, because he has all his feeling playing Bach like that. It's not in the musical shit that Johann Bach wrote. So I think about this example, and
All right. No, I think you answered it. All right. Thank you.
All right, any other questions? Yeah.
Thanks for the talk. Mine is very short. I was wondering, so what you demonstrated was like a small one, like small samples of data, right? I was wondering if you tried something big, like, did it come to something massive, interesting?
Yeah, I don't know. I don't think I have something in mind. No, you said if I have something big.
Yeah, I was just wondering if you tried it with a large set of data.
Oh, cool.
And if the music that came out of it was, because this one was a little bit morning music. I don't know, maybe that's because of the pace. But I was wondering when there is lots and lots of data, something else comes out.
Yeah, you'll probably come with some chaotic too, because there will be a lot of stuff there. Yeah, but in this case, I only worked with those data sets. But yeah, I think I will try experimenting on other things just for feeling happy.
All right, there was another one here.
Yeah. First of all, thank you for the presentation. I loved it. My question was this: while you've been testing with converting data into sound, have you been able to accidentally reproduce an existing music piece?
No.
No? All right. Nothing even close?
No,
Okay.
I don't think.
I'm gonna try to. Thank
no, but,
you.
Yeah, funny. Oh, you said that. I saw some examples on the internet that people playing music based on the data sonification, like they get a band together and then they start playing based on the melody that was getting on this. So, yeah. In the case, I never played something that I remember some melody before, but some people transform some music based on this later. Opposite.
So I wonder if you could use this music as a back channel or constant thing, and how would you approach it? In the sense, for example, we have our production logs, and like they are fine, and there's mostly like info logs, but for example, during peak hours, there's more people using the service. That could somehow translate to, I don't know, higher pitch or something, or then the number of errors could be a dissonant. Have you played with something that runs constantly, or would it be too distracting as a back channel of information?
I don't know if I get the answer. Sorry. No.
Is it like real-time monitoring, like you just have something that is going to be playing sound based on like what's currently happening on a server. Was the thought.
That's fine. That's a fun experiment. But it was a question. No, I never did this, but you give me a good idea. No, I was. It was hard to understand because I didn't get if it was a question. I'm sorry, but that's a good idea.
So my question is more about, did you, while doing this multiple times, were you able to like memorize some patterns? So some people doing it on data, analyzing data and plotting some graph, they will see patterns just looking at the graph.
Okay.
Did you experience something like that?
The first data sonification that I did here, it has a really strange melody, but it got stuck in my head. Yeah, it really stuck in my head because I played a lot of times training this presentation. But yeah, I think it suits good with visualization too. So it's nice to enhance the data visualization. But yeah.
I think we've got time for one more. Any other questions? All right. Well, thank you, Carlos. It was entertaining and great talk. Thank you.